Hey, welcome to Coffee Compiler Club. Here today to talk about compilers and language runtimes and implementation details of all sorts having to do with code generation and language implementation. Usually no set agenda, and the conversation rolls where it is. Everyone's being recorded live. These are all old timers. Everyone knows that. And you'll be up on YouTube within, who knows, an hour a day, something. So I have the one leading agenda, which is last week I was really hoping chapter 21 would be done. It's been a week of steady progress on chapter 21. So what happened? Well, it's a laundry list of random, looking at the GitHub histories, a laundry list of random things come through. And this is just a symptom of where we are in the strat. God, Zoom is being evil again, as usual. Why is Zoom being evil? Fine. In the implementation. So one of the things going on here is that after we have an evaluator for pure simple nodes and we see that we're running code and it works, it's sort of like a bad version of an interpreter. We go to instruction selection. Well, now you get a pile of nodes in a graph that in theory represent x86 RISC ARM instructions. There's no way to test that you got instructions that would do what you wanted to do, really. Then you go to register allocation, and again, it looks like a good allocation, no way to test. Then you get to encodings and you want to spit out ELF files or whatever. Now you can start testing. So 3 chapters worth of, and big complicated chapters worth of stuff are getting tested in the last rounds of chapter 21. So looking backwards over the last week, there's been a bunch of things having to do with uh, uh, making simple more portable, because Derek's been working on a proprietary closed source port. Um, and a bunch of encoding bugs that just come around hither and yon. Uh, that are just cornery cases that don't show up so often, so they didn't hit the initial runs. Um, we missed cast ops. ARM didn't have a nil, a way to produce a pointer nil as opposed to an integer nil. A bunch of infinite loop bugs that are still going on. Where you have essentially a server that's running in an infinite loop, and he has continuous IO stream output, but no, he never exits the infinite loop. So he's dead from below. So when you do instruction selection, which is a bottom-up greedy walk, it's bottom-up greedy because on things like an x86, you can fold together by first touch from below an add to memory or an add immediate or whatever, because you match the low guy. And he says, well, wait, I'm an add, but I know how to do an add immediate, one x86 op, one ARM op, one RISC op. Look up, do I have an immediate value? Okay, do the thing. Um, so backwards walk up from below never enters an infinite loop. So your infinite loops don't get walked. So you don't get instructions selected for them. Ooh. And so that's, buggy. So we fixed some of that stuff. That turned into more layout issues, where suboptimal branch layouts happened because the intelligence for the infinite loop handling guy wasn't there necessarily. Missed negate is a simple, has a straight up, has a negate and a not. And negate is really zero minus whatever, but it's one op because that one's kind of common and easier to fold in some situations. So if you spot a zero minus and switch it to a negate, you can often do more things afterwards. Didn't have those encodings, got them in. We got the evaluator for RiscV evaluating new new allocations. And that meant all of our test cases, of which we have quite a few now, that do an allocation as part of their normal processing, will run under the RiscV evaluator. So the RiscV evaluator was this thing I pulled from the interwebs from a guy. Maybe I can find his name while watching. He did a pure C version, with a reasonably open license. So I made a Java version and credited him. But it's a one file RiscV emulator. His version will boot like Linux. It's like pretty serious. I cut out a lot of the OS specific things because I'm just trying to do user mode only things, simplified. Made a Java version. find a handful of encoding bugs that were just transcription errors, um, getting it running. So it's pretty solid. And I believe the encodings that it parses are good. So when I go generate instructions, we discover a few RISC encodings are broken. And then we discovered, I wanted to do call a new allocation. I'm using malloc, calloc to get the zeroing, pre-zeroing out of it. That means I need to have call instructions to calloc get patched as if in ELF you would do a remote patch. So you would produce an ELF file, you produce a relocation info. Well, I have the relocation info. I actually need to do it to call the emulator. And then the emulator hooks and says, I have a call instruction and it targets a calloc, which I know about. And so I'm going to emulate it internally. So I can now run a bunch of these things. We found more bugs that way. Um, didn't have some leaf function tracking correctly done. x86 lets you align or less or more aligned call stacks if they're leaf bounded or not. Um, what was the other one? Kill masks. Oh, yeah. So we have this funny thing on x86. So x86, we test strategy is produce an ELF file, link against it, and run it, and then verify the output. All done basically from the Java driving the process. Java calls GCC, links the file, compiles and links a C driver, and then compiles against the ELF file we've generated, and then runs it and captures the output and verifies it. Okay. I'm running on Windows, so I compile and link a Windows OS and a Windows calling convention, Win64 MS ABI. And then the CI and a couple of the other, Zmilia at least, a couple of the other guys who test on this run Linux all the time, or Mac OS maybe. And so they want to compile and link with System 5 ABI. And of course, it's a cross compiler, so it can handle them both, but it has to be told which ones. So we had it running on Windows testing Windows and on sys5 testing sys5. But I didn't get WSL. I burned 3 hours, 4 hours trying to install WSL, and I could not get it installed. So I'm not testing on System 5, and I wanted to. So I put a hack that said, hey, I can turn on System 5 under Windows and tell GCC to use System 5. But then I have to link against libc. And libc on Windows is MSABI. It's pretty obvious. So then I needed the calloc call to link against the OS local for me, but I can make GCC call the driver code with sys5. Sys5 gets called, sorry, the driven ELF file from simple sys5. We can check excessive count of arguments and weird float int mixes and all kinds of stuff. And then, my other compatriots don't have or are compiling under whatever, but they're linking and running on Linux. And so they need sys5 linking and compiling with Windows wasn't working. So the test harshness were breaking for them or breaking for me left or right. So we sorted that all out finally. Now the normal situation is you test and link to whatever you're told to on the simple side. So simple says you're taking a Win64, you produce an ELF file with Win64 linkage. And then you better link against a Win64 libc or sys5 if you've said sys5. And then you can run these things. So at this point, we can reliably run Windows or sys5 under x86 and all tests pass and link and calloc and everything just goes. When doing the evaluator, it doesn't have a libc linkage because the evaluator doesn't go out to libc. It just runs internally. So it only has libc internally, so that doesn't matter. So the evaluator is fine either way, although he has to pay attention to libc arguments, the calling convention for what registers hold the arguments to calloc. That's fine. Win64 has a shadow stack where registers that are arguments passed in registers need a matching stack slot that is available and assumed crushed by the callee. And I wasn't doing that. Now I am. That made me revamp how stacks were done. That made me revamp how everybody does calling convention math because everyone was doing the same math in 3 replicated files with a lot of cut and paste redundancy and off by 1 bugs for everybody that were different because it was all cut and pasty and sort of incrementally grown over time. So I yanked a whole lot of the calling convention math, put it in a common place. Now the machine ports specify like a list of registers that are on your the caller save. And I build the callee save variants and which get clobbered and which don't without any other help. I need to know what your return register is, but then I change up all the callee saves on the return masks and stuff. A lot of stuff got cleaned up there and moved into one place. So yeah, calling convention math got revamped along with stack counting, so shadow stack slots are done correctly. And now we pass all the tests on ARM and RiscV and x86 where you pass 20 arguments of every other kind, so you're forced onto the stack left and right. The calling convention one was a big one because in addition to changing the math or removing it to a common place, there are lots of places where people had accounting. So everybody who did accounting for, so function call headers and returns and call entry and call exit, all did a math accounting for stack frames, all got changed. The news, which for Calyx, which again went back and forth between sys5 or OS local or what you got told, changed. Geez, what means we're in the splits change. I changed some of the names and somehow the math was done for stack slots. So splits, which handle spilling to the stack, all changed. So, there's 20 files changed right there. Like 6 to 8 in every CPU architecture. So 3 architectures times 8 files is 24 files plus the shared common place where they would pull from now all changed. So that was a big one. The RiscV emulator kept picking up either picked up float extensions. That was the big one. The C program we picked up from the interwebs from this guy, didn't do float because he was intended to do embedded RiscV. We're essentially running the embedded version, 64-bit embedded version, more or less, but we picked up the floats. We had math problems with constant pole offsets. You wanted to do like the test Newton was like, go pull up 1/2 and 2 and you're multiplying by half and you're adding 2 or whatever the hell the test Newton does. It's floating math with floating constants. Well, the constants are 64 bits. You don't want to build them up with a pile of integer ops and then move them to a float register. So you go load them from a constant pool, which wants to be in a separate address space than the code pool so that you can make the code memory space execute only and the constant pool not execute, read only, no writable, and that's pretty common. Well, okay, now you need relocation information for it for you go out to an ELF file, and now you also need, if you're running it on an emulator, you need to do those patches yourself. So that all got sorted out. Odds and end bugs with like wrong encodings for the FP ops that now showed up because we hadn't tested FP ops before, so it just had minor bugs in the encodings. What was another big one here? The next big one was branch inversion. So this is like a stupid, non-obvious problem. Like who thinks or who would have thought that you'd have to go deal with this thing? But you come into the instruction matching and you're trying to select instructions and you have a compare op, you're doing a branch against a constant. Super common to compare against a constant. Okay, so the compare comes through, he's got some value in a register on the left and an immediate constant on the right, and you want to match that. Okay, so you got to compare reg immediate. That's great. So you come in through the matcher again, you got another one that's got an immediate on the left and the register on the right. Well, it turns out that an x86 can't do that. The immediate has to be on the right. Well, okay, it's easy. You flip them, but now you have to swap the test. Okay, so you flip you do a swap on the test. And the swap on the test means is instead of 1 less than n, it's n greater than 1. So the swap says less than becomes greater, less equals becomes greater equals, equal stays the same, non-equal stays the same. That's a swap. Okay, as part of that, having swapped that, the compare op on an x86 doesn't record whether you're computing a less than or a greater than or less equal or whatever. It just says, I compare these under all conditions and set off like bits. So following a compare, you have either a jump or a set to a 0, 1, to a Boolean, forced to Boolean, both of which do take a less than or greater than kind of thing. But the thing they take, the lesser or greater, is swapped or not according to what the comp did. So you have to decide to swap the jump or swap the sets test condition if the compare swapped. And this was done on x86 for some flavors and not others. So it wasn't consistent. And so the test that earlier had working when I was trying to run brainfuck, which is now getting, it's a pretty large test, or certainly larger than anything we've done so far. Crash and burn took forever to sort out that we had inverted tests because the jump had not picked up the swap where the set CC had picked up the swap. Same thing goes for load. You can compare on an x86 a register versus memory, but not a memory versus register. And the matcher would go ahead, instruction selector would go ahead and pick those, swap them, and then not tell anybody. So the following jump would be inverted. So after those, and it turns out RiscV has a worse version of the same thing. They only do a less than test or a greater equal. So they don't do a less equals or plain greater. You have to get those by swapping. Okay, so again, you had to play the swap games and you had to pass the flags around and get that all sorted out. So then after that's done, you go into basic block layout where you're trying to lay the blocks out in a good order where the loops all run through and then have a backwards branch to the head. And in the body of the loop, the exit tests go out. That's the obvious one. But in fact, you're handed a random scribble scrabble and you come through and you've got a loop header. Okay, and then you hit a branch. Does it go in the loop or out of the loop? Which way is it going? It's usually 50-50. It's wrong half the time. You want to negate the test. Negate the test is subtly different than swap. Negate the test says a less than wants to become a greater equal. Swap says a less than wants to become a greater, not a greater equal. So you have to have it invert the separate function from a swap. And that wasn't done correctly on all architectures either. So that one was another couple days of sorting out the odds and ends. And then Tommy, I don't know how you pronounce his YouTube, his Discord handle, decided that he wanted more testing on ARM, and we had this RiscV emulator. He just cloned it, made an ARM emulator that did ARM encodings instead of RiscV encodings. That's a hell of a piece of work. So, hats off to Tommy here. So that showed up, and immediately we find, ARM encoding bugs. Some are his and his new thing. Some were in the ARM encodings as we had already. So a bunch of testing went on ARM, and we find all these encoding bugs. Occasionally you'd find register allocation bugs where not in the register allocator, but in the machine description file reporting what registers are available. ARM had like the floating point offset from the start of the floating point regs, the end of the GPRs to the FPRs was 31 instead of 32, which led to an encoding bugs where all FPR regs are off by 1. Which went into the emulator and ran off by 1 according to what the arguments got passed in versus what they were encoded as. And so that was yet another screw up. Kind of seemed to slowly settle down. I think right now, Tommy was working on 1 or 2 ARM bugs, and I'm working on another version of the infinite loop layout bug. Like there's an unexpected infinite loop issue, and here I'll just put this test case in the docs. If I can go find the actual doc here. Yes. So, to thank, hats off to, oops, well, that was why did you do that? Okay. Let me reformat this in Emacs and then go paste it. Because the Emacs at least gratuitously had huge, weird spacing things. That was weird. Yeah. So it's a dumb infinite loop, and it's really dumb. And it just says, it's not really infinite. It just says count with two the hard way. Um, and the layout guy was producing a most ludicrously bad layout or just plain old incorrect. Uh, we was missing jumps because he got confused by these set of, no, not interesting jumps going around left and right. So this plus a couple of infinite loop ones that I actually have infinite loop ones is what's the other infinite loop one sitting in my face is something like, well, I think I have it as an actual, I'll just write it up again here. Let's see here. Capital S is equal to a new S, that X plus plus, and then it's an infinite loop, so you can't ever get out. So this kind of a thing where you're updating the contents of memory throughout the loop, that had been an issue. So that's where the week went. Um, all kinds of encoding bugs, all kinds of jump inverted, left, right, not inverted, inverted versus swap versus negated things going on. Picked up an ARM emulator and promptly found a bunch of ARM encoding bugs. Cleaned up the RISC encoding bugs. There were several. Um, yeah, and I think that's my story for the week there. Oh, there's where you hit the share. So that's my chapter 21 rant. I still think it can be done at some reasonable point, not too far. Figure out the infinite loop things, and then maybe, maybe we're done. Um, done enough that I'll take bug fixes in the encoding afterwards and look at chapter 22.
Which will be?
Oh, we gotta have strings,
Huh.
strings and IO.
Okay.
But there's other things that are really interesting to look at. Don't get me wrong, but I think first up is strings and IO. And then behind strings and IO, there's some thinking about doing memory management strategy. And I'm trying hard to not do GC. I might leave a hook in place that I can conveniently do GC or not. But the default answer here is that for a malloc, there shall be a free, but I don't want to do it with malloc free. I'm looking for some support, whether it be borrow checkers or ref counting or something. Ref count, I guess, falls into the GC category. So I don't know. I'm kind of sorting my head around. Surely I can do something about a better version of the borrow checker, at least one with less, I want to say less egregious overhead when you write signatures for, you look at Rust, people doing signatures for borrow checking. They have a bunch of complicated signature things they have to write, and everyone says it's really hard. And once you get past the hump, it's just tough. But you get these great memory management strategies out of it, which lead to robust, fast code. Okay, that's nice. Then another thing you look at is, oh, well, we can't do like shit like cycles and stuff because lifetime management. So everybody who's building a graph, a version of simple in Rust, first thing to do is say, give it up on pointers and just go straight to indices into an array of nodes. Like, okay, that is a strategy. But when you gave up on pointers, you gave up on all the goodness that comes with pointers, like saying pointer dot field. Can't do that. You have to say array of index dot field, and that kind of is clunky. And it's like, come on, can't you do something better? That you got a pointer that's declared to be lifetime managed in an arena somewhere, and therefore I can say pointer dot field and be fine, and I can free the memory when the arena goes or whatever. There's something to be done there. But that comes after. So strings first. At least you can say hello world. Getting to hello world. We're not yet at hello world. In the land of C programs, hello world's this funny memeish joke because it's the first thing you do, but it's also the hardest program to compile on the planet, sort of per line of code. It has IO, it has var args, it has function calls, it has strings, it has all kinds, like every bad corner case on the planet shows up for hello world. Fine. All right. That's my rant of the moment.
Kind of seems like if you wanted to build a Hello World compiler, you could probably skip a lot of the things that you did, though.
Yeah, you make printf not be var args.
Right.
Oh, the things I did?
I mean, a
No, you
lot
have
of
to
the
make function
things like
calls.
in simple, like you could do
Yeah.
if your target was like the minimum compiler to get to Hello World without just, saying, oh, Hello World
Oh.
is this set of bytes.
But that, I mean, yes. So the obvious things are like, I just have an intrinsic that takes a string. I have string as a built-in data type.
Yeah, exactly.
But as soon as you have strings as a built-in data type, you're still looking at all the normal compiler things you'd like to think about, plus also strings as a type. Then
Well, you could do the
then
Erlang thing where strings are just arrays.
well, I'm headed for, yeah, strings are just arrays. It took me a while to get to arrays.
Right.
Arrays have memory, have state. The first like 5, 6 chapters in simple do not touch state because it's too much. Somewhere around 7 or 8, I touch memory and you have state now. And then as part of touching state, you have to do a new and you get into an allocation strategy, you get to memory management, you get to aliasing issues, loads and
Oh,
stores.
Hello World is small enough that you could fit it in registers.
But then it's not strings. That's different.
No,
That's
but
I
just trying to
loaded
think of
these
what's the
bytes.
absolute minimum thing that you can do to. It's like, yeah, you can't do strings longer than, 16 or 32 characters, depending on your architecture.
And then the parser just knows to pack the strings in a register, and then the printf is an intrinsic, like malloc and calloc are intrinsics. And he
Yeah,
takes args and registers that have characters and just slams them out.
just print one character at a time in a loop.
Yeah, you might as well just do uppercase only and limit yourself to like 32, bits worth of characters, right? Then you can
Yeah.
pack every 5 bits and out of 64.
Double your string lengths.
No, you just null terminate. Just do nulls at the end. You don't need a length. What the hell? If you ran off the end of the register, it was done.
Yeah, yeah. That's what I'm talking about. A minimal Hello World compiler.
Okay. No, I didn't do the minimal. I wanted a compiler that would compile something more exciting. I tell you what, it was very exciting for me when Newton float worked and generated valid, good answers. Like, I
Yeah,
actually got square roots.
yeah, that is pretty impressive.
That was fun.
I should probably
Other
put that one over to
things.
Python and see if I can do it. Oh, I
Sorry.
don't have floats. Can I do it without floats?
Yeah, I have an integer version as well. But you have floats on
Okay.
your extra side pieces. You just get
Oh,
low
yeah, I
res.
could. Yeah, I could put the floats into the PE array and do it. Oh, that could be
Yeah,
interesting.
yeah, yeah.
Not the most efficient way to do it, but who knows?
Well, no, you just have to do 100,000 in parallel.
Yeah, that's true.
It's all good. Um, geez, what else would I was just about to say? I don't know. So, strings. I was going to say, what's the design point for strings? So my current theory is I'm going to merge arrays and structs, make them a unified data structure, and there'll be a prefix of named fields and a suffix of an array. Um, And then as part of having named fields that's constant values, I can put functions in there and they become methods. And that's already 90% done. So probably hand in hand with strings will become method calls, with just a little syntactic sugar. Lisa wants to eat. Oh, Summit Store. Yeah, maybe. Okay, fine. It's really miserable out up here, and I'm trying to decide if she really knows what eating at the Summit Store means. It's really nice there when it's a mountain store. We're up in the mountains, but it's a mountain store. Sun's out and shining. You go get from the deli and you sit down out in the open, basically in a park, and eat your sandwich. It's really pleasant. When it's socked in and foggy, and the winter storms are blowing atmospheric rivers over the top of the mountain, it's not so nice. But shit's growing fast right now. We have gotten a ton of water this year, and I cannot keep up with the yard now. It has now reached the point where my medium duty weed whacker cannot cut them on I need a scythe or a heavy duty backpack powered weed whacker or like a bushwhacker. And last year my neighbor pulled out his bushwhacker and did my lawn. It's on a 35-degree slope. You can't run a lawnmower reasonably on a 35-degree slope. And it's gone from mid thigh high to above waist high, and it's rapidly hitting to shoulder high. At 1 year, one spring's worth of growth,
Wow.
and at that point you just can't. Sort of the wimpy little lawnmowers you see people do their suburban lawns. That's not going to cut it.
The last time I heard the word bushwhacker was when I watched Blazing Saddles.
Yes, DR55 bushwhacker. It's like a 55 horsepower Uber self-powered lawnmower with big, heavy, wide wheels, so it won't tip on the 35-degree slope.
Right.
And it's nothing you want to push, so it's self-powered, but you drive behind and steer the thing, and it'll take out, things that are like 1.5 2, 3 inches round. It'll chop them up and take them all in one pass. Instead, I have foxtail, which will wrap around my weed whacker head every stroke. So I'm out there using the weed whacker like a scythe, and I sweep it through, and then 2 passes, I have to turn it off and pull the wound around grass layers that have choked it up off and then go again. And that's because I pulled my back at the start of the grow season. I missed a week. Then it rained, and I didn't want to go out and weed whack in the rain. And then I had a clear day, and I took some small section out and realized that it's gotten really bad. And then it's rained and rained another week and grown another foot in a week. And now I'm up to like bushwhacker. Sorry,
Need a
unrelated to
machete.
compilers. Clifford's exercise is to go spend an hour out on the lawn once a day.
Yeah. You gotta get one of those machetes like jungle
I
mode.
went looking for a scythe, and they would sell me a machete, but I didn't want to bend that low. So if I
Oh.
was doing a machete at shoulder height, so I could just see over the top of the foxtail, that would be one thing. But I'd rather have a scythe and take it off down at ground level. So what happens here is it grows up like this, then the rain quits and the grass quits, and by midsummer it turns brown, and I have a shoulder high version of stuff that'll light with a match and flash fire. It's a super fire hazard. You just have to take it down. So some point it dries and they're easier to cut, but at that point it needs the DR55 or a scythe. I went looking for a scythe this weekend, and the local Ace Hardware didn't have one. So I need to look a little further so I can find one. Kind of an unusual ask,
Yeah.
but 35-degree slope is not something you can do normal things with.
Oh.
Fine. Okay. Maybe compiler things now.
Okay, so what's the story about introducing new nodes? So my 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 thinking here is all of the base operations are already introduced all the way to encoding in instruction selection and but if you introduce another node, so how easier I would be to introduce a new node if
A
I need
base
to.
node.
Yeah.
Yeah, sure. I would claim not hard, having done it 1,000
Mm.
times, but
Mm.
me versus you, whatever. So suppose you want to put a conditional move node in.
Mm.
The conditional move node takes a predicate and 2 values and picks one. But it doesn't
Mm.
take control. That's the whole point. And it can be moved around as a non-control based value.
Mm.
And if your underlying chip architecture you end up targeting doesn't have a conditional move, then at some point you just encode it as a branch around, the reg alloc puts one of the values in one registers and the other in another register and the predicate somewhere, and then the encoding says skip around a move. All right, it's 2 ops, but you hide it in the encoding and it's all totally local to the encoding, so no one ever sees it there. So then how do you go implement such a thing? All right, you go pick the nearest looking node that looks like what you're doing here. This is just takes 3 inputs and produces 1 output. Pick an add node, for instance, as a starter point, clone it, rename it, conditional move, put some predicate, put some little helpers to say the predicate's in slot 1 and the first arg in slot 2 and the second in slot 3. You have a node. Now you have to go actually, use it in a sentence or find it. So now you need a peephole matcher, and the peephole matcher for conditional move would be, I have a phi function. It's merging 2 things. The phi comes from a region who has 2 inputs. The true false comes from a test. and the test says, I test something, and then I pick. And you need the region to pick from the same if, and the phi is the two values, and the region finds the if, which finds the predicate, and you replace the phi with the conditional move. If you replace all of the phis with a conditional move, then you'll have no phis left on the if test, and there's already a peep that'll say, have an empty branch, just throw it away. Don't have a region that merges nothing, and then the test will die. So you end up with a pattern that says, I produced this node. I have a node, now I have a pattern which produces the node. Presumably some optimizations now are enabled because of that. I may want other peoples that say things like, if the condition eventually becomes true or false, you pick the left or the right. If the two things you're merging become equal, it doesn't matter which one you pick, so you pick the one. You put the obvious peoples in to go clean things up. Now you've got a node. It runs through the ideal optimization pass. It does something useful, maybe. Come down to instruction selection. You'll hit a to-do that says basically, what's the instruction? What's the hardware instruction for this guy? Now you have to go say, well, okay, we go put in the matching
So
equivalent.
that's what I'm trying to say. Can we move to a world that you need to just describe some this node is set of base of operations which are implemented by this node, and you don't go all the way to instruction selection. So introduce like a framework in which you have most of the base functionality, and you say this functionality, like you said, use fees and something like that, and you don't bother to encode it because it will dissolve to a base operations which are already instruction selected and encoded. So
So an example of that is a call op with inlining. I'm not claiming this is what you're targeting or what you're thinking of. I don't know what you're thinking of,
mhm,
but a call op looks like an op. If you choose to inline, it explodes into a bunch of other ops that are all understood how they generate code in the long run. And things
mhm,
optimize for a while, and
yeah,
the ideal pile of nodes cleans up, and
yeah.
you go through instruction selection. There's nothing to be done because you don't have a call anymore. It's just whatever piles of bits you came from.
Yeah.
So maybe get concrete here and say, what are you thinking of?
So I'm thinking like introducing like a helper functionality which doesn't all the way always need to go all to instruction selection, because I think right now simple is encoding and using and implementing almost all of what you need from some programming language. And if you need to introduce something that is not yet introduced, you at least have to move it just on the way that you say how it's implemented by the base node functionality, and it will handle all the things auto encoding. You don't
Right.
need to deal with that. So
So,
you kind of framework for not helping you as much as it can to that level.
so I mean, I'll say that's there now in the obvious and maybe not what you're still missing. What your intention here is, you take your fancy node and you
Mhm.
explode it into the existing nodes. Those existing nodes are the ones that know how to instruction select and cogen, registrar allocate, and things like that.
Mhm.
Matrix
So
multiply. You have a
yeah.
matrix multiply node you put in as a high level because you extend the language to include matrix multiplies.
Mhm.
And you want to do things with matrix multiplies for a while where you reorder the order they compute in because there's an obvious winning strategy. It's just like SQL queries with joins. There's an obvious winning strategy of doing
Mhm.
things that force reduction before you explode out and whatever. So you do a bunch of things at a level that says, I have a matrix. I know how to do matrix multiply. I know how to adjust for scalars or whatever. A bunch of things you might want to do while it's still known as a matrix.
Mhm.
And then at some point you say, I'm done here. I can't make any more progress. I'm going to drop the matrix multiply down to component parts. Suddenly you get a triply nested loop, or you probably get a function call off to something. But somebody does some math and says, well, if the sizes are all small and the thing is known to be little, I'm just going to inline or whatever. But you're done with it. You've just put a
Mhm.
call in as a idealizable call. The call inlines to triply nested matrix multiply, which other
Mhm.
things know how to produce.
Yeah, I'm talking the way you kind of go to a more abstract way, like the MLIR thing, which picks the things on a little higher abstraction, and it can use you to
Yeah,
introduce new functionality.
that's what
That's
I,
what.
well,
Yeah, yeah.
I feel like I just said that. I didn't
Yes,
say
yes.
MLIR,
Yeah,
but I
yeah.
said start with something, matrix multiply is a high
In
level, screw
yeah.
with it for a while.
Mm. So you don't need to I know that, but if you introduce a new node, you don't need to mess with the other nodes to see to tell it how this new functionality has to be implemented.
No,
It's
you
like
do.
expression program.
No, you
Yeah.
do. So I introduce a new node that says, make me God. And then I do whatever what I want with it. And then I need to go actually implement it. New node says, reverse this crypto password.
Hmm.
And I do magic things with it for a while. And then I need to go implement the thing. Well, there's no reversing strategy here.
Mm.
I make a new node that says, give me an anti-gravity belt. Now I have to go implement it at some point. I need a strategy that takes whatever magical new node you put in and produces something that knows how to make it actually happen.
Yeah. So
So
that's
you
why.
have to put that path in as part of putting in a new node. It's all great to have a matrix multiply in.
Mm.
Then at the end of the day, none of the hardware has a matrix multiply.
Yeah.
You have to actually implement something.
Yeah.
Because it's such a wide variety of things, there is no strategy, there's no generic strategy that says, take a thing I've described in words and
Mhm.
produce machine code out. That's not, we're not to that level of
No,
AI
no,
yet.
no. I mean that you have to describe it how to dissolve in the
Yeah, if
nodes
you describe how to dissolve, then we're there.
that's
Make your
yes,
node,
yeah,
describe how to
yeah,
dissolve, done.
yeah. Yes, that's what I'm trying to say. Uh,
Okay.
so yeah, we have that, but maybe is there helper functionality that need can be made easier about
Um,
that, or is easiest as it gets? So you tell it that it.
yeah, so in the land of C2, we ended up with a lot of strategy. We tried a lot of strategies to break complicated nodes down
Mm,
into bunches of parts.
yeah.
Um, that turned into, the thing that was stuck was basically a toolbox
Yes.
that would, you still had to call the toolbox, but it made it a little more convenient to do this explosion out into the raw underlying nodes.
Mm-hmm.
And
Yeah.
there was a lot of that kind of thing going around.
This was.
Early on in the Parser, you could Parser helper, go to the C2 code base and the Parser helper, places like that, you start finding these toolbox pieces that said, I know how to do a min or a max and explode it out into nodes. I know how to do I don't know what
This,
all. There
yeah.
was a bunch of things.
This is, I think, essentially what MLIR is all about. So
Yeah,
describing more on more high level what the operation needs to
right.
be and how it boils down to the more base operation.
So
I think
somewhere,
what Theodore is driving at is that we can also separate lowering from optimization. So you
Mm,
can define
yeah.
nodes in MLIR that do not have lowering strategy, so that you do not know how to break down into more primitive operations, but you can still optimize them. So like we can define nodes like the matrix node and the vector node, and you can tell that these are, for example, pure operations, that they do not have IO, that they are not exposed from above and below. And then you can write a generic common sub-expression elimination pass that is able
Mm,
to do something with them.
right.
So
yeah.
that's kind of the level of abstraction. You
But
can have IR
Yeah.
only with the
but Matt, where do you go
effect
from there?
strategy.
I've produced a magical node that doesn't know how to come out to machine
Mm,
code. I can see it, and that's in there simple right now. If you just put a node in and it's all functional on inputs, the generic CC will pick that one up straight up. Code selection, that's code selection, code scheduling will totally handle pure or not. That's all there right now. The question is, what do you do with this thing that you don't know how to lower?
mm,
Well, so actually depends. Stable HLO, for example, is only for TensorFlow. It's only a representation dialect in MLIR. So you just want to store a model, maybe you want to simplify the model, then you want to store it and pass it to some other framework. And that other framework can be written by a different team, that a different company, and they're gonna implement, for example, execution for their custom hardware. And it may be proprietary, it's not even going to be shared. So it's kind of, you can completely decouple the work done by the optimizer team from the work done by the lowering team, for example.
So there is a lowering strategy. You're not
implemented by
right now.
someone, possibly in a different framework, possibly at a
Yeah,
different
somebody
company.
has a lowering strategy.
Yeah, someone has a lowering strategy, but
Yeah.
it's completely modular and completely decoupled.
Yeah,
Right.
that's what I'm trying to drive at. Thank you, Matt, about that. So it's not immediately obvious, but all the nodes introduced in simple has to go all the way into
No, they don't.
instruction selection.
No, they don't.
So some of them or most of them, I don't know.
No,
So
none have to. I have an evaluator that's an interpreter. I can
Yeah.
stop before. What I did before instruction selection was I stopped with just pure idealized nodes. Then Zmilia wrote an emulator, and I eventually rewrote it. But there's an emulator, and the emulator runs like an interpreter. And when it hits to a node, it doesn't. It knows how to do all the nodes. It has an execution strategy for the nodes. So if the
And
node
I
was a matrix multiply, you would just do the matrix. It's like APL. It'd be like bytecodes for APL or something stupid. So you could stop there and you could emit a file at that point that somebody else could pick up and read and discover that you had done some optimizations but hadn't gone down to machine code and they wanted to go to machine code. So right now, Derek is intercepting at a point where, right at the instruction selection point, because he has a bunch of new nodes added for his custom hardware and a bunch of RiscV nodes that are just a standard RiscV, ideal nodes that map to RiscV. And in his instruction selector, he comes up with machine ops that are some RiscV, which have encodings that came from simple and just look like the same old simple things, and some that come from his custom thing, and they're all weird and they do funny, weird, bizarre things. And he has a bunch of new nodes he's added to support the weird custom hardware. Now he's intercepting and going all the way down to machine code, but he's taking the standard control flow, if less than, greater, min, max, whatever, from RiscV and going out to the end. But he could stop. I mean, you could stop in the middle and just say, I'm done. Like go up to like chapter 18, stop there. You got
But
ideal
if
nodes.
you if you introduce, let's say, a matrix multiply in the idealized stage, you have to return a node, but you have to personally foresee that this node eventually will go to instruction selected or what. So how would you do? How would you replace that to say the matrix multiply should equal these amount of nodes in
Right. Depends what your goal is.
I do this all the time, so maybe I can answer this. Like,
okay.
Sometimes I, going through the docs or going through the sources, I find some op that I didn't realize that people are using. And so then it's like, okay, this is something that's not supported at any point in the compiler, but I have to add it because it's a custom op. So I have to add parsing for it. And then I parse that into an ideal node that if there are some peeps, like for instance, I may be able to discover this node and say, oh, actually I can turn it into this other thing, which is better. Or maybe I realize, oh, this is better, and I can actually turn something else into it or some other structure into it. And so
But
then basically that's all in the peephole side.
Do you turn it into something that is already known, or you transform it into
I just
something
add
that...
another node class. It's like a few lines of code.
Yeah,
And
okay. So how do you foresee all the way to the end?
I don't have to foresee
At which
it.
point? Okay.
So just like you parse, you like, I'm going to need a node for this thing that I'm parsing because it's a new concept. So then I create the class. Sometimes I can subclass it from something, or sometimes I just subclass it from a raw node. But regardless, it's not a lot of code. Like it's a handful of functions to override methods, and then I have to add a backend node, which is like the machine specific node, and just put a line in the switch statement saying select this node when you see the, it's like I see this ideal node, here's the node that I get, and then add the encodings for it. And that's it.
So
this is a simpler version from what I'm hearing Matt and Theodore talk about. You have a single ideal node that maps to a single machine node, and you're putting in both sets of the mappings, and you're expecting to map through.
Yeah,
Yes,
it's up
yes.
all the way
That's
through.
what I mean to that for C2. All the way how to instruction select it, how to encode that into a base instruction. What we are talking, at least to me, it seems to me Matt is also talking about, is to not go all the way to instruction
Yeah.
selection. So at some point you need to dissolve that node into something that it's already know how the rest of the pipeline will encode it. So
That
that was
that
we're
would be
talking
just
about.
a peephole transformation that says, oh, this structure or this node
Mhm.
can be like it can be restated as this other structure or
I'm
node.
Yes.
hearing like three different things going on here.
Okay.
Derek, you have a plan that works for, I was told, a new op for the hardware that someone basically wrote a high level hook for saying, use this op here. And then you generate a simple op. You eventually match it to a hardware version of a simple op that knows how to do encodings.
Yeah, and sometimes it turns into multiple ops.
Then there's Matt saying, I want to put something in that has some high level things that you do, certain high level common optimizations like CSE, some amount of constant folding, but it's still something fairly high level. It has no direct hardware mapping. And furthermore, I'm not even going to go do that mapping. I'm going to let somebody else deal with that. So I want to intercept the pipeline of the compiler and emit something. And I have that intercept point. I don't have a disk file format that you would write out. So there is a version, or there's a thinking that says we could add here's how you write out a disk file format. So if you wrote a matrix multiply and you transformed on them for a while with other matrix multiplies, you didn't want to actually deal with the back end or encoding, so you just spat it out to a file, somebody else's problem. And then I
Somebody's
hear Theodore saying, if I had something high level and I did something for a while, what is the strategy for go ahead and getting something I can encode and run out? And can't I not have to deal with the
yes.
actual encoding pieces
Yeah.
for which my strategy, for which my answer is, you still have to then map to what we do know how to do encodings for. So you
Mhm.
have to decide how you're going to explode that guy.
So there is the explicit lowering steps to something, to a fees, to a
Yeah,
bunch of things that knows how to represent that high level feature.
yeah.
So yes, I think you got that right. Yeah.
Okay. And there's a strategy which, like the APL folks do forever, which was you go to a function call. I have a matrix multiply. I'm not going to emit for it. I'm going to just call out to some C library routine. This is the Python strategy. Um, and then the only thing we have to agree on is the API, the register allocator, put the pointer to the base of the array somewhere. The memory layout of the array is a known format. The C code that picks it up and calls Blas knows the layout, and then he just arranges to call Blas, who does the matrix multiply and comes back. And that is a lowering strategy. Same solution for SQL join optimizations on Link or whatever the Microsoft, mixed blended C and SQL query strategies is about. You have a set of things you're optimizing the normal way on for whatever reason you're optimizing. You're done. Write it out to a disk, somebody else's problem,
Mm.
lower it. You're going to get code out, lower it via just calling function calls. You get code that way.
So that explicit lowering step needs to at least know which set of nodes are
Yeah,
the
and
base operation. Yeah.
to give an example, sometimes it can be very simple, like one-to-one. In MLIR, for example, you can convert from SPIR-V direct, which is used for things like GPUs, to LLVM-IR direct. And they are basically populating so-called conversion patterns, which explain how to do map things like add operations in SPIR-V to add operations in LLVM-IR, how to map things like the Boolean type to Boolean type in IR, and integers and floats and on and on. And most of these are, if you look at the sources, it's just one-liner.
So
This
so
compare operation goes to that compare operation, yada, yada,
th
yada.
this is more how they align, how the types align, or how they.
Types and operations, because dialect in MLIR is basically an IR, which is comprised of types and operations. So you can convert from one dialect to another. This dialect may be on the same level, it may be higher level, it may be on the lower level. So as a fallout, you can implement lowering by conversion.
Yeah,
Yeah.
I'm trying hard to not support multiple dialects per se. like there is now in simple, same as C2, two dialects. There's ideal and there's machine. And they are basically nodes. Node edge management is unchanged. Walking the nodes, iterators over the nodes is unchanged. The types are unchanged. However, the machine ops do not support peeps, and they do support register allocation, register masks. They do support scheduling, basic block notions. There's a bunch of things they do support that the ideal nodes do not, and vice versa. So there is a translation step there. Now, having more of those, I'm funny about where the goal of the compiler is. Doing things with like matrix multiply or SQL query optimizations is still something that sounds reasonable in Sea of Nodes in my head. Bailing out early and going to a disk file seems reasonable. I don't have anybody clamoring for that use case, and I have limited time, so that's how far it's gotten. If one of you guys wants to pile in and say, I want to go write a writer reader for simple, I'll take a PR. I'll even pile in on my strategy or my theory about what I would think I'd like to see in a reader writer for simple nodes, but I'm doing strings before that. And then probably memory management, lifetime management, which would, I think, play big with, matrix multiplies as well. They all got tied up in lifetime management too.
One of the most natural things to implement is data structures like hash table optimization, red-black tree optimization. You really don't want to lower to a red-black tree to individual assembly like instructions and then try to optimize this, because that would be hell.
Right. You put a hash table node in the graph and do hash table optimizations for a while.
Right, or even some like data access. There's this paper representing data collections in SSA, which basically boils down all data structures to very simple memory SSA-like operations.
I have seen this paper a long time ago. Can you find a link? Like I remember seeing this go around even while I was at Sun. I want to say a long ass time ago, and just never had time and energy to go deal. It was like, oh, this sounds cool. Yeah, a hash table that you put things in and pull things out. It totally does not. It would support load store optimization, except that you compiler will not sort that out.
Okay.
Bill says, here's
the paper I was thinking of is from the last year CGO 2024, but there has been prior work. So
I'd say, okay, yeah, sure.
But the one from CGO 2024 is pretty cool because they handle multiple variety of collections, both hash tables and other, and they pretty much just boil this down to very, very elementary operations like read, write, copy.
Well, they have a huge reference site section.
Oh yeah.
I imagine that going back for some history here. Here is December 1974. Structured programming with GoTo. I don't know why that one would be referenced here. But there are certain things from 2005, a bunch of them, 1991. That's just SSA in general. See, I don't know that I saw this necessarily in an SSA flavored thing. So
Swift also has something like that, Swift compiler.
Okay.
It has this SIL or Swift Intermediate Language, and that can represent some data structures, like arrays, I think.
Yeah, I mean, I got arrays and simple.
Of course, Fortran compilers have multi-dimensional arrays. They usually have like array descriptors or dope vectors. We can describe it like even you can pass a sub-array to a function, and even though you are inside that function can actually know what part of an array is it an array of, which you can never do in C. And you can pass information like stride, offset, so maybe you are just going through every second element, but you can still know where is it coming from, what is the original array. So that's kind of cool.
I would, so simple does not have, I'm going to say we call dope vectors or slices, but that would be a thing to think about as a basic type, or at least a well understood by the compiler type of this slice. There's definitely optimizations that can be done on a slice that are useful. Pointers are complicated. That was a fun paper, the pointers are complicated paper. Fine. A lot of things that I'm trying hard to avoid by having a strongly typed language that C folks have to think about. Oh, don't do that. Come back. Thank you. Windows trying to grab the edge of the screen and do things. Fine.
So I'm curious, Matt, about this paper. Is this stuff that's being done in LLVM, or is this is just new research or something that's interesting, or is this present in MLIR or
So
what?
one practical implementation is something like this is done in Swift, but Swift uses its own intermediate language called SEAL, or Swift Intermediate Language, and it can represent things like arrays and the access to array, update array. It's Google for high-level optimizations in SEAL. It's going to be in the Swift repository. Other than that, the paper, they actually implemented this in their own version of LLVM when they added a whole layer of representation, which is basically PDG, or program dependence graph. And they implement this on top of that. And they added basically a few nodes on the LLVM IR level to represent the basic elementary operations that are common to all data structures, independently of whether they are, say, tree or hash table. You always do things like read the value at key, store the value at key, that kind of stuff. And you want to abstract from things, whether you use traversal, like separate chaining in hash table when it's a linked list, or maybe something like a red black tree when you traverse the tree. You just want to have a higher level, so update, right? They might have even published an artifact, like a source code repository, which works on their implementation. And I know their LLVM fork is open source, so they do have that one on GitHub.
I guess it's difficult when you're trying to do this against someone's library because you'd have to be kind of bug for bug compatible with their whatever that code
Yeah, and it is an existing library like the C++ containers. You do have to actually annotate. You're not gonna magically reverse engineer this from the meaning of the source code. Even Swift, to my recollection, so Swift implements its own data structures too. And
like
to my
internal.
understanding, they do annotate those array operations, whether this is an access, whether this is a read, whether this is a write.
So it's sort of like good for the language internal data structures, but you're not going to easily tie into that if you're trying to build a library.
Yeah, user.
If it's some random third-party library, then I think that's a harder problem to recognize what is what.
Right. Right. This would
Depending
be
on the language, of course, if you have some language with effects, then you can probably infer this from the effect system, but I would
everyone
still...
has memory effects, so you always
Unless
have
you're
effects.
yeah, or unless you're planning on doing like what was that Chris Latner project where he was trying to make it so that your language had like MLIR integrations? Do it there, I guess.
Mojo?
Mojo, yeah.
No, no.
They do have some library optimizations in Mojo, that's true. They even had a talk at last year's LLVM dev meeting conference.
This is like actually, they were talking about that, and I was racking my brain trying to think what anybody would ever use it for. But in fact, this one seems theoretically like a use case.
No, the paper has other than some listing one, example one is not true. I guess I'm halfway through. They're doing a good job of pulling out the common obvious things that every collection has that every compiler would normally optimize for.
Yeah.
If you can see the wholeness of the collection from the parts.
This actually seems like a really good basis for doing generative testing of data structures too.
One of the things that we tried hard in C2 was to pick up on, Azul was to pick up on hash table, these kind of data structures, but using the transactional memory when somebody was cheating to save your ass and unwind. We had some things that were like we know that you're trying hard to fake a hash table here, so we're going to go through and claim that we can fetch a read optimization and act as if it didn't touch the state of memory, and then we had to run it through something. We're doing something with transactional memory to unwind if you were not actually following the read-write rules. It didn't go very far. It wasn't, there are too many generic things. Like we intercepted Java hash table and could make that go with manual editing, but we couldn't do generic peoples, but we tried hard for a while.
Seems like you could have to unwind really far.
Well, right. The unwinder was the size of your L1 cache, which meant, it was really good except when it was really bad. So it was L1, four-way associative. So as soon as you had 5 updates to the same line, you lost it, and that was it. You blew out and said, I can't transact this, so I'm going to die now. You unwound at that point and said, the transaction failed. I didn't get to the end before I lost the line. But you could do forwards guaranteed of updates and not have any issues. It was reasonable. Hash table himself failed because he had a hard user visible write because he had a mod count. And so he definitely updated the mod count field, which meant that the next transactional write to parallel unrelated fields had to have a serialized mod count field because one of them knew the mod count was 2 and one knew the mod count was 3, right? Kind of thing. So it didn't help unless you turned off the mod count. So you had to go edit the source. So then it was not hash table. It was Azul's hash table. And that would transact through updates and reads and writes and be, perfectly good at dealing with unrelated key value stores. Fine, never mind. There was a reason I got here, and it had to do with I was trying to do this as this kind of a thing for a while. I knew it was supposed to be a deal, and people wanted me to do it for generic containers, and I couldn't do it. So yeah, if there's a straight up, I put a container in the language, you use my language-based container, you get this optimization. There have been papers on people trying to reverse the lowered form to a container. This one says optimize on a container. That's great. I swear there's been papers that said reverse this base level structure and discover that you're a container. I'm looking at Matt. I wonder if he can pull a miracle out of his hat, but I have no idea.
Wouldn't that be a lossy conversion though? So I believe if you go from the lower to a high level, there are multiple ways to go about that.
I don't know if it would be lossy or not. I mean, if I just gave you the source to hash table or hash map, told you it was hash map, and can you discover that it's hash map from the source code? Besides, blatant pattern matching, is there something that says, how about an array list? Here is an array list implementation I hand wrote by happily copying the Java array list or the C vector class. Okay, reverse it, discover that it's vector class. Now it's a container and it has the following container properties. Can you reverse that? All right, did I make a little diddly fiddle change to it? Did I break its container-like properties? Can you adjust and say, it's a container as long as I do the following check first? Like, what is the limits of, can I discover a container? And that's, there, I don't know. So a vector array list container says I have a base, I have an array, it has a max capacity and it has a current length.
Yeah.
And even that part of saying the max capacity and the current length have an invariant where the length is less than or equal to the max.
So that part is actually being implemented in Clang and GCC for security reasons. So Linux kernel uses that because they have a lot of their own data structures. Like, they have those intrusive linked lists in structs. Okay. And they also store some random integer that actually happens to denote the length of the list. and then they have some random traversal function that may or may not go out of bounds. So they wanted to introduce some security checks to know that this function accesses this data structure which has length stored in this integer in this struct, and we should never go past the number in that integer. And they did add that kind of bounds checking
Do
by
they
annotating the so
annotate?
they yeah. I
That was
think
our
it would be
question.
really hard to reverse engineer because you can have
Okay.
struct with like dozens of integers. Only one of them is the length. So how would you know?
Right.
You would have to like look at the loops
Okay.
and infer from that. But if you're looking for the loops and the loop itself has an off by one error, then you have inferred this with the off by one error.
So, but the annotation is possibly limited to this field is the max, and well, the length, and this field is the capacity, and this is the array. And these three things are annotated or linked together somehow. And then somebody can come along and say, you're supposed to be an array list, vector / whatever, and we're going to length check on you. Java, at least, it throws the capacity in with the array. So the array and the capacity get linked immediately. But the max is generally off to the side. And simple, one of the goals of merging those together is that the max and the capacity and the length would all be co-resident in the same structure. But I don't have any sort of intent to annotate to the compiler that max is less than capacity or length is less than capacity. If I did, then there's probably, well, we pick up all user-made versions of the same thing.
So if I got that correctly, what you're trying to say is to work with that notion of containers in the sea of nodes directly. Is that?
Yeah, right. So those are separate problems here. One is, can you lift up to a container? And then the second one is having a container. I want to do like SSA optimizations on the container as if it's a memory field in a struct. Certainly in structs, I can say I store at the name, the key is the field name. I store at key and a value, and then later I load from that same key, and I expect the same value, and the optimizer can say, you stored here, you loaded there, poof, I'll just get rid of the load and use the value you stored directly. Maybe even later the stored field goes dead and I can toss it all together and in register. And there the key is the field name and the value is whatever you're doing. Okay, now in a container, it's the same notion, except the key is something that's a runtime thing, like an index and an array. But maybe it's a string that's person's name and the value is their address or whatever. But the same notion of a key and a value having this property that says unrelated keys don't touch, exactly equal keys exactly touch are the same thing. That's exactly what loads and stores on struct fields do. And that's the equivalence class aliasing all over again.
Games. Yeah.
And then when the keys might hit, it's array indexing flavors of aliasing, where I say, I don't know what this index is. I don't know what that index is. Maybe they hit, so they alias. On the other hand, if this index is 0 and this index is 1, they don't hit. They don't alias. I know that. And I can do things. And I do things there in C2. I mean, simple just hasn't got there, but that's a straightforward hack to go do in simple. So I think there's something to be done there. Certainly the case that hash tables and container class objects are extremely common and would obviously benefit from this kind of optimization.
This fits in the teams, like working in a sea of nodes with a more higher level representation of them.
Yeah, just like declare a container array as an instance of a container class.
Yeah, so it is.
Yeah, and then if you had a container thing, you can do container level optimizations on it, and then the arrays would pick it up. Right now, I do it with arrays. I say, oh, you're an array. Yeah. You have some set of rules. If you're a struct, there's no aliasing on the keys. That's great. If you're an array, there's aliasing on keys, so there's less things to be done. But there's definitely things to be done. If I can prove your container is using unique keys that are known ahead of time, then you're just a struct of another flavor. That happens a lot in JavaScript, actually. People do, I bet in Python too. People use dictionaries where the keys are just hard-coded strings in the language. I just wrote a bunch of strings. That was my keys. And then having shown that they're just all strings and they're all known at constants, I want to say TypeScript, one of them, FlowScript, TypeScript I used, would totally spot that and say, this is basically a container that's, a hash table, but it's not. It's just keys and values in a struct with the named keys or strings instead of field names. And he would do type analysis on that. I assume it would break as soon as you said, oh, you had annotations if you were going to break it. Yeah, he did some of the annotations there to make his life better. I don't remember now what. You had type annotations you added, and you could declare a thing to be basically a hash table, but it was keys were field names. You could declare it somehow that way and say, I'm treating this like a container. It's actually kind of convenient in some ways because the strings would be, if you broke the rule on strings, you get yourself screwed, the uniqueness of the strings. But otherwise, you could get the strings from a file or a setup thing or download to the internet and then say, oh, these are my keys. Go to town. I don't remember where I used that. I used it a bunch of times. Blob int void counted, yes. F-bound safety now accepts the community. So someone here, this is Matt's thing in the chat, is saying, here's how we're counted by. This is a container class where you're specifying an annotation to say, this is related to that. Yeah. What's the right, good, bad language design that says, oh, this is Futhark. Where's Futhark when you need him? Where's the guy who does Futhark? Yeah, all your bounds are related somehow. So there's some language you're using to annotate, describe this array has bounds of n. That array has bounds of n. So if I say for loop on the two arrays, I can do, without actually doing a zipper, I can move between them or whatever. I can iterate along them simultaneously. He had a bunch of other things he was doing with array bounds. Fine. All right. Everyone's quiet except me, so it must be time for me to shut up too. Something else. Or I'll stop and go sort out my lunch at the Summit store. Simon, you came on late. You got anything you want to add? You're here for a reason, or you just were bored and got your beer?
Oh no, I just didn't have a reminder.
Ah, no problem.
Because today is holiday over here. So, but I
Yeah.
found this interesting article on query engines, push versus pull. Did anyone? Let me post
What did
the
you call it?
query engines, push versus pull. Did
Oh,
anyone see the article or read it?
Well, I pulled it up here. I will.
I read the paper from the database angle when it was introduced, the so-called hyper paper. I believe it came in 2011. And that actually has a pretty good reasons to introduce the push. So basically, you can think of what Clang compiler does as a pull-based compilation strategy, because you have an AST, like an abstract syntax tree, and when you compile, generate IR for this, an entire AST node contains every information you can pull from that syntax tree. So you're going to have a function which is going to have a statement, which are going to have a nodes, which are going to have information like the bounds in the loop. Whereas in the push-based, you would actually be starting bottom up and pushing this data incrementally. So for incremental compilation, push-based strategy has some advantages. That's one thing. And this top-down versus, it's actually tight one-to-one, whether if you're gonna be going pull-based compilation or pull-based query execution, you are going to be tagged to doing this top to bottom. Whereas if you are going to be doing push-based query execution, you're going to be building from the bottom to top, from like in the individual data to the higher level concepts on those data. And push query engines have some advantages. Oh yeah, they even mentioned that the pull-based is Volcano. That's correct.
Yeah.
There are very good lectures on this at the CMU database. If you just Google CMU database lecture, it should be like first result. They have actually a course now, which is, I think, one of the 2 courses on the planet Earth. The other one is in Germany, TIM, actually, that goes, the Technical University in München, that goes through the implementation of database query optimizers. It's very, very rare to actually have a good course on that, well, almost non-existent. So that's what I would recommend on that.
Yeah, the impression I have is that this discussion happens largely from like the general purpose programming perspective. But if you look like at mainstream databases and that documentation, it's like it's not a real thing. They don't talk about pull-based or push-based query because I think from the perspective of a database runtime, they have a query planner and they implement the query in whichever way they see fit and
So
run it.
no, the distinction does happen. So Microsoft SQL Server is going to be pull-based because it's based on Cascades, which is based on Volcano. It's the people who work in academia pretty much were the people who implemented this database query engine. Whereas a database like DuckDB, which is this SQLite for data analytics, they switched to the push-based query execution because they had higher performance for their workloads based on that. So there is a pretty strong overlap between the academic work and the database implementation, including the same people who work on the teams who implement the database engines.
Okay, but it's not as I mentioned, it's not something that's if you open the documentation of a database, they don't
It's
write it
not
there because
that
it's
common, but again, Microsoft did document their SQL Server implementation in a bunch of papers and a big book that they published recently on the query optimization. And DuckDB also talks about this in their documentation because it was kind of their selling point from the marketing perspective that they had higher performance when they switched to the push-based query execution. So
okay.
if you can tie it to a general audience, like if you have some numbers, you can show that you win on benchmarks, then you talk about this. But oftentimes you don't start talking about internal implementation details if it's just something that is like relevant for your team. So that's why it kind of depends. And it's a relatively new concept. The push-based, again, it is like, yeah, that paper by Thomas Neumann, it's like 2011 or so, which is, just a bit over a decade. And given how much it takes from the academic research to propagate to industry, decade is like a day old. So most people maybe are not yet aware of it, except people who are really in that deep on the query optimization in database engines.
So I wanted to ask because I mean this is in theory a compiler club, but if you because like Rust, they were like very hyped about how they were a pull-based architecture. They were like, oh yes, we have this salsa, it's like query-based, nothing is like, pushing through the system. It's all, sort of demand-driven as terms of how we do these, questions about type inference and stuff. And so I was wondering if anyone had thoughts on that.
Sorry, not me. I've heard Rust also, but I haven't stared at it, so no idea.
Yeah, I don't know how much they integrated in their mainline compiler. I do know that what they use for LSPs is based on that. I keep forgetting the name. It's a really generic name, something like Rust Query or something.
Did you say LST in there?
LSP, Language Server Protocol. So
Okay.
their LSP implementation uses that strategy.
There's another thing for simple, a language server. Yeesh. Fine. Sorry, Alan, doesn't sound like there's a consensus here, or there's an opinion.
All right, I guess I'll have to research it myself to see. Because yeah, you're right. I think, well, I know they use LLVM as a backend, and like obviously once it gets to LLVM, like they're not, they're just pushing it through. They aren't, doing any queries on it. So
Derek, are you going to add something?
Yeah. So going back to the sort of data structure optimization and stuff a little bit, I was thinking about the like the idea that memory is sort of like if you have a write to memory, that's considered to be inviolate. So you never don't write to memory if a memory op, like a memory write, emerges in your program. At least that's my understanding of how it's treated. And yet sometimes stuff that's going into memory is like pretty easily traced out, and like it's just temporary. It's like no real reason that it needs to go to memory. So like, is there a way to distinguish that and say this memory we don't care about?
It happens all the time. So
Oh yeah,
store after store, the first store is dead because the second store stomps it, assuming that you cleaned any in between loads out. So that's how
right.
simple.
But yeah, so store after store is understandable, but that's still saying that that's memory location is inviolate, and so it's like we're still put. Go ahead.
There is a distinction in that in MLIR. So if you encounter things like terms like bufferization, this is when you go from a high-level IR which has tensors to low-level IR which has memrefs. So tensors are abstract SSA values which do not have a memory allocation and just represent an item that may or may not end up in memory. Maybe you just have some huge tensor, some huge multidimensional array, but you only ever going to work with a subset of this array. You don't want to memory allocate. Maybe you're going to fuse it with something. Maybe you are going to eliminate it. So before this, you just work with those abstract SSA values, which denote multidimensional arrays. Those are tensors. At some point, you are going to go to a lower strategy. Maybe you even have to decide whether this is going to live in the GPU memory or this is going to live in the DRAM accessed by the CPU. That's called the so-called bufferization, when you actually have a concrete physical real memory allocation corresponding to that element. And from that point on, you convert tensors to memrefs or memory references. And the concept of memory reference is actually we circle back to dope vectors because it has been inspired by dope vectors in Fortran compilers. It basically denotes the base, offset, and stride of the memory allocation that you have, because it may be based at this and this address. Maybe it lives in the address space corresponding to the GPU memory. Maybe it lives in the address space corresponding to the CPU memory. So you also store the address space. Then you're gonna have the offset. Maybe it's a part of a bigger allocation, maybe not, because you may have a memref that is a sub part of some bigger memref, and maybe you access this every second element or something, then you have a stride. And of course, you can do more optimizations on tensors because you can rearrange them, slice them,
you treat them like a
poke
value
at them,
object.
whatever. But at the moment you introduce memory allocation, the moment you go through bufferization, you have less opportunities.
Right.
Which
you
kind
treat
of
them
makes
like
sense.
a value, though they're bigger than what fits in a register, but you treat them like a value.
Right.
Which is what, I mean, I do that in simple, not in simple, I do it in C2 all the time. Simple's not there yet, but it could, would, should be. Anything that you can say, this is a value, but maybe it's too big to fit in registers. I don't care. Some point during the lowering process, it'll go to memory. Meanwhile, it's a value. I do value object things on it.
But just the parts that you care about go to memory. Or the whole thing.
When you're doing value object things on this fat guy, whatever it is, and you're done with things and you have to lower, part of being done typically means I threw a bunch of it away. I didn't care no more, so I got rid of it. Like I made a struct, but it didn't escape, so I treat it like a value object. Now I have a struct as a value. It's on an edge in the IR that carries the whole value, the whole struct. and accesses to it just do field slices. And there's no aliasing with this struct or anything else because it hasn't escaped any, it hasn't escape analysis saying it hasn't gone anywhere, which is trivially true right after its allocation. So that one picks up by C2 directly, and simple is very close to that. Having a value object in my hand, I now can add, subtract, multiply, and slice on it, whatever, and then I'm done. And at some point I say, oh, I'm going to escape the pointer, or I have to live with it. But I also might say at that point, the following updates to fields, I can throw away. I don't care. The original zeroing, I've replaced with something. These fields are dead. I don't want them anymore. So I'm going to make a new struct that has got fewer fields. Or maybe the whole thing just goes dead.
And the aliasing is actually the big one. That's what you get to. When you know it's a tensor, it's an abstract value, this is just something that cannot possibly alias with some other thing. But when you have memory, well, that's just a memory allocation. Now you may actually have to do some alias analysis to prove that those two members do not alias. So that's a big one. That's a big distinction.
So the C2 version of this says I did a new, it doesn't alias, period, end of statement. So I keep it as basically as a separate alias class, which basically everybody knows about it. So they basically treat it like it's a value. The whole thing is a value object. They may want to look at one part or another, but they're treating it like a value object for a while. And then I hit a point where an escape happens and I have to have an edge in the graph or node in the graph that says I gather all the pieces, parts, and I throw them into a memory, and now I lost it. Then it's a memref. So yeah, we talked earlier about doing, say I had a giant matrix multiply and I'm doing other matrix multiplies and I want to reorder them, and then the intermediate results get smaller or whatever. I'm doing optimizations. Those are all giant arrays treated as value objects. And then at some point in the lowering process, there's obviously memory involved.
And of course, it's always more annoying to do optimization at the lower level, because think of even if you have constructed a stack frame and you have allocated stack offsets to your local scalars. So now that every scalar already has now its stack offsets, and now imagine you have to do things like dead code elimination. You're gonna poke holes in the stack frame. So what do? Do you defragment? Do you run a defrag pass that basically coalesces everything together? I mean, you could, but
no,
it gets messier and messier and messier.
Dead code elimination.
Yeah, exactly. So there is an order. To doing things in a compiler that is more natural and less natural.
Okay, fine. Yes. Yeah, simple. Those things are all done before you lower to stack slots. And they don't allocate, like C allocates things directly on stack, and simple Java strong type does not allocate directly on stack as part of the language semantic. So if you got something on the stack, it's because it got spilled there, which still means it doesn't alias, and everyone in the IR knows it doesn't alias with anything else. It's just got a new unique special register number that happens to be SP plus offset instead of RAX or RBX. All right. Where are we at here? The sun is trying to come out. I might yet go to the Summit store and get a sandwich with my wife and sit out in the park and eat it.
Just to answer Alan's question, that was Rust Analyzer that's using this strategy. And there is like a long YouTube lecture series of someone who implemented Rust Analyzer that walks through the architecture and the implementation. I think if you just look at YouTube for Rust Analyzer implementation or something like that, you should be able to find this. It was pretty good.
Sorry, I'm writing documentation in the documents. Oh, that was another one that came out. Doing simple. Somebody said, RPO, what's that? And as a compiler guy, longtime compiler guy, I don't know what I don't know. So it's reverse post order. What's reverse post order? Well, I don't know if people here know or don't, but it's you visit things by walking from the start and heading to the bottom. And then on the unwind, on the post order, you mark them somehow. Generally, you put a counter that says this is the post order numbering. and then you reverse that order. Reverse post order. What good is that? What the hell is RPO good for? Well, it's defs before uses in a fairly natural way, except at loops, which obviously have issues because you can't have defs before uses at a loop. It's a common strategy for compilers to have an RPO order lying around, and then they can visit the program defs before uses except at loops in a fast linear time scan really quickly. Just I walked a list of things in RPO order and it's just a straight line sweep. And that in turn has a bunch of efficiencies for optimizations, and not just efficiencies, but the optimization's done in one pass as opposed to I kind of sort of got to the end and I didn't get everything. So I had to go back and I had to go back and I had to go back. And how many times did I have to go back? Well, I had to go back a lot, and maybe, exponential, something stupid. Algorithms get simpler and get faster both. So RPO order is a common compiler writer strategy for.
By the way, there is a cheat to remember it's really basic, the basic name. So imagine you have a graph which is representing A plus B, right? So you're gonna have a plus as the parent, and you're gonna have A and B as the children, right? A plus B. So now think of the post-order traversal, in-order traversal, and pre-order traversal corresponding to the prefix notation, infix notation, and the postfix notation. Are you gonna have plus AB? Are you gonna have A plus B? Or are you gonna have AB plus? And that's exactly post-order is the postfix notation, for example.
I have my HP calculator with its reverse Polish notation sitting on the shelf. I guess it's upstairs. It's, my college calculator was RPN. Exactly.
And we care about this. And we care about this because generally compilers will have graphs instead of trees. Yeah. If we only had trees, then the DFS or the depth first search is just DFS. Yeah. But in graphs, you have different DFSs, and those three are the most common ones. And RPO is, then, as Cliff said, very, very useful because it has properties like defs before uses, which is exactly what you want.
Yeah. So the RPO ordering for the loops with infinite loops was giving me issues. And then when that got sorted out, I had other RPO orderings that involving negating branches to get the RPO order that I wanted, which was I wanted the loops to be contained. So it's not, there are many RPO orders that are valid for any given graph, but there is one that says I had a loop. I had an entry, I had a loop body, and had an exit at the bottom, and I wanted to visit them in this order, as opposed to other valid RPO orderings, which would interleave things. And for that, I was doing swaps and negates on branches and hitting bugs.
Even like this A plus B definition, you want to have first A and then B before you do the plus. Otherwise, you wouldn't know what you're adding. So that's also like sense.
Yeah.
So, I just wanted to say to that, the original thing was that they were confused by this RPO term. And so like what I found is that like ChatGPT is helpful for that. Because you can just you're just right. Here's what I want to say to this person, and then like spit it back out, but less confusing. And it'll like substitute terms, like it'll change RPO to post order traversal or whatever. And then, somehow that will be less confusing to the other person. Right. They won't ask me as many questions after I write that.
Right. But because they didn't ask any questions does not imply that they got more understanding. They just might have decided that you're using ChatGPT, which is a piece of crap, and they should quit asking you.
I mean, right.
I think you turned your mic on.
Yeah, I was gonna say something, which is like I think the first time I heard RPO, I think I was confused the first time I heard it, not because I didn't know what a reverse post order walk was, but I'd never seen it like acronymed like that. Because
I was acronymed when I was at grad school 40 years ago.
Yeah, no, it is a strange acronym, but like because like when I think of it, I think of like where's the O?
Order.
Like because is it capital R, capital P, then lowercase o because it's like post? Or is the O from the order because then pre-order and post-order both have the same acronym? That was the confusion for me.
No, PO isn't an acronym. RPO for reverse post order is an acronym. And I had it hammered in my head. Everyone was using it at grad school 40 years ago. It was not like a weird or strange. It was the normal. It's too long to say reverse post order. So RPO.
Yeah, makes sense. At this point, I do use it regularly, but yeah, I remember
Right,
nothing
right.
like
But
maybe a
not
year ago
everyone
or
has seen
something.
it, and even in the
Yeah.
compiler community today. And so I needed to define the term in the simple documentation because in the comments just said, and here I do an RPO, and then da 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 da, and away you go.
Yeah.
Yeah, so like you run the simple documentation through ChatGPT, then maybe people will not ask as many questions,
are
and they'll say, "Oh,
welcome.
I'm using more modern language." So yeah,
You are welcome to do so and see if if the output is more or less understandable. You are setting yourself up here, and I am calling you to task on that.
you okay? Like I don't know, which one is the best one to start with? The most confusing.
No, that's the
Or
issue I
Yasser
have
might
because
know.
I don't know what you
Why
don't
don't you
know.
ask ChatGPT, which is the most confusing?
Oh no, it's
Excellent.
really bad at that kind of thing. It'll just say
Excellent
they're all
answer.
confusing. So, hmm.
I think this is a self-limiting problem.
All right. Hmm.
Walk
Well,
away is the easy answer.
we'll see. I mean, if I submit a pull request, we'll see what happens.
I will totally look at the pull request.
Yeah.
There's other pull requests I'd like to see too, including any and every things to do with memory management and or writing simple out to a disk file and then loading it back in. And I have a strong strategy theory thing I want to try on that, but I have no time. I have way more shit I want to do than I have time to go do. So
Yeah, actually, no, I know what would be productive is like reading through the simple documentation and making sure I understand it.
that would be because if you don't understand it, there's a thing to be improved right there. And that would
Yeah.
be a case where you would read it, not understand it. I would ask you to write it in your own words, what the part you didn't understand, and then I try to clean that up to make that suitable for a wider audience. But that would be a lot of the documentation came that way. Somebody said, I don't understand what the hell's going on here. And I'm like, you don't? I don't understand what you don't understand. And then we went around and we came up with something that sorted them out. Yeah.
So, all right. Oh, okay.
I'll
Something to
definitely
do
take
this.
that kind of PR.
All right.
Okay. In a handful of seconds, I'm going to declare victory for the Alliance and claim that I really, really badly want to get simple chapter 21 pushed this weekend and declare it done. Portable code gen. That's actually reasonably correct. All right. That's it. Until we meet again.
I
Bye-bye.